Hey mathematicians, here are your notes 1.1 for classifying numbers. So the first thing you're going to see on your note sheet today is this visual at the top. And what this visual does is it represents the relationship that different kinds of numbers have to each other. Now obviously there's no numbers up here, and that's because there are letters that represent different groups of numbers. So let's go through what those groups are. Notice all numbers are real at this point. We will get to a point where we talk about imaginary numbers. However, right now, we're just going to focus on those real ones. So, the most basic number we have is sometimes called the counting numbers. These are the natural numbers, and they're the numbers that are used when you're counting things like pennies, the simplest term. Next is the whole numbers. They're not fractions, they're not decimals, they're just whole numbers. The main difference between these two is that whole numbers includes 0. Next up we have the integers. Integers can be whole numbers, or they can be whole numbers with negative signs in front of them. People often refer to the integers as the positive and the negative numbers. Next up we have the rational numbers. So these have integers and fractions and decimals. And they're any numbers that can be expressed in the form a divided by b, where a and b are integers and b does not equal 0. Lastly, we have the irrational numbers. And these are just the numbers that cannot be expressed as a fraction. Notice they are non-ending and non-repeating decimals. So, now that we have kind of a general idea and some better terminology to talk about these numbers, I want to go into a few examples. So if I give you the number 1 and say name the set or sets of numbers to which each real number belongs, which sets would the number 1 belong to? And yes, I did say multiple because they can often be, as you can see here, in multiple categories. For example, 1 is a natural number. It is one of the examples we see up here. So I would put an n, a natural number. However, it is also a whole number. There's no fraction or decimal associated with it. But because it's part of the negative and positive numbers, it's also an integer. Notice integer is kind of the tricky one. That one is denoted by z, not by I. I is used for irrational numbers. But we have to go a step further. Not only is it a natural number, a whole number, and an integer, it is also considered a rational number because we can divide 1 by 1 to get 1, and therefore it is rational. And of course, it is real. You're often going to see this bold R to denote real. We don't have to put this for the rest of these examples, but I did want to show you that real is often denoted as that boldface R. So I'll actually make that note up here. Real numbers, not real hashtags, real numbers are denoted by that bold R, or sometimes just R. You'll see it different ways for different people. All right, let's do another one here. The square root of 49. Simplest way to think about that one is to just make it a number that you recognize. 7 is another simple one. It's just like the number 1. It is natural. It is a whole number. It is an integer. And it is a rational number. We can divide 7 by 1. We can write it as a fraction, and it is still nice to us. All right, I want to give you just a minute. I want you to pause the video, go through and try the rest on your own, and then come on back and we'll do them together. All right, hopefully you had a minute to pause that, go through those on your own, and now we'll go through them together. The number 1 million, simple one again, just like the two we did before. It is natural, whole number, integer, and rational. Again, it's real. I'm not going to continue to write R because, as I said before, all numbers are real at this point. 0. 0 is the first tricky one we have because even though it is a whole number, it's technically not natural. Natural does not include the number 0. However, it's a whole number, which means it is also an integer, which means it is also rational. Notice based on our table up above here, if one is inside of the other category, it by its nature must be the next biggest or the next smallest category. So if a number is a whole number, it is also an integer. If a number is natural, it is also a whole number. Whole number, it is also natural because it's within that category. Excuse my mix-up. All right, the next one is -5. That one is going to be an integer, but not a whole number and not a natural number. Again, it's still a rational number, still a real number. All right, I'm going to do a little less explaining on the next ones. Still a real number. -2/3. That one can still be expressed as a fraction, so it is rational and it is real. I keep wanting to write r, you can if you'd like. 4 1/5. -7.18 can be written as a fraction. It may not be a pretty fraction, but it is possible. Right here we've got a non-ending and non-repeating decimal, which automatically puts this in the I category. Still real, but it's irrational because we cannot write it as a nice fraction. Next up, we have pi. Pi cannot be written as a nice fraction, so that is an irrational and a real. And then the square root of 5 cannot be written nicely either, so that is both irrational and real. I apologize, I actually want to jump back up here to number 10. This is not irrational because we could eventually write that as a fraction if we had enough zeros. That one is in fact a rational number and a real number. I got confused based on the decimals there. My apologies for that. Even math teachers make mistakes. If you have any questions, don't hesitate to let me know.